External land forming processes, part 6, oceans, seas and their coasts. Objectives. By the end of the topic, the learner should be able to distinguish between oceans and seas, describe the nature of ocean water, describe water movement in oceans and seas, describe wave action and resultant features. Objective number 5, the learner should be able to describe the type of coasts, and lastly discuss the significance of oceans and coastal features. Let's start by definition of terms. And the first term that we want to define is oceans. Oceans refers to vast bodies of saline or salty water on the earth's surface that surrounds the land or continent. So what should be noted here is a vast body of saline water that surrounds the land or continent. Examples, we have Pacific, there is Atlantic, Indian and Arctic oceans. Seas can be defined in 3 different ways. The first way is that seas can be defined as large salty water bodies surrounded by land or saline water that lack connection with the oceans. Example, we have Caspian Sea, we have Aral Sea, Dead Sea. These seas lack an outlet to the ocean. They lack an outlet to the ocean. The second way that we can define sea is large salty water bodies joined to or separated from the oceans through a submerged rock seal, or what is known as a strait. Example is Mediterranean Sea that is connected to the Atlantic Ocean through a strait known as Gibraltar. Others in this category include Red, Black and Baltic seas. Lastly, seas can be defined simply as smaller divisions of oceans, also known as marginal seas, i.e. they are at the margins of the 4 oceans. We have the Caribbean Sea, the Arabian Sea and the North China Sea, among others. So that is how we define oceans and seas. Distinctions between seas and oceans. So here we have differences as well as similarities. So the similarities here include both oceans and seas contain saline water, as we have seen the definition, and 2, their waters are in constant motion due to waves. So those are the similarities between seas and oceans. Then we have the differences between seas and oceans, and here we can say that 1, oceans are affected by tides, whereas seas are not affected by tides other than marginal seas. 2, oceans have strong ocean currents, whereas seas have well-developed land and sea breezes. Number 3, oceans surround continents or vast lands, while seas are surrounded by vast lands or continents other than marginal seas. Number 4, sun-lit eastern coasts of oceans lead to coral formation, whereas seas experience or lack coral formation whether they are sunlit or not. So those are the differences between oceans and seas. Nature of the ocean water. And the nature of ocean waters, the following aspects, that is saline water, temperature of ocean water, ocean topography, ocean life and ocean pollution. So we are going to look at them one by one. The first one is saline water. And it should be noted that the source of ocean water mineral salts are mainly: 1. The ocean water dissolves soluble mineral salts from the rocks, forming the ocean bed. The second source is that a lot of salt is added to the oceans from rivers, springs, which flow over soluble rocks, and therefore these salts are deposited in the ocean. Then lastly, we have volcanic eruptions in the ocean bed, which generate huge amounts of soluble mineral salts, adding to the saline nature of the ocean water. We should note here that isohalines are lines drawn on a map to show the places with the same salinity in the ocean, that is isohalines. So that is saline water. We have factors that influence the salinity of ocean water. The first one is latitude, and this affects the salinity of the surface water. The salinity is lower at the equator than at the poles. The greatest salinity is around 30 degrees north because of higher temperature causing evaporation. Salinity is low in temperate oceans due to low evaporation rates and melting ice being added. It decreases towards the equator because of heavy rainfall and less evaporation due to high humidity and more cloud cover. The second factor that influences salinity is the depth of the water. So the surface water is generally more saline compared to the bottom water. The third one is the amount of fresh water added into the ocean. So areas that have got a lot of rivers flowing into the ocean will have low salinity, as opposed to areas with little water being added into the ocean. Factor number 4 that influences salinity is the position of the inland water. Seas located in regions of high temperatures have higher evaporation rates, hence the water is more saline. Lastly, mixing of water, surface water and water below the surface makes the level of salt in the water to be fairly constant. So the rate of mixing also affects the salinity of the ocean water. Next we have temperature of the ocean, and it should be noted that ocean water temperature is not uniform, i.e. it varies depending on the following factors. 1. The latitudinal position of the oceans, where oceans found in higher latitudes experience lower temperatures as opposed to oceans found in the lower latitude that experiences higher temperature because of high insolation. 2 is the depth, where temperatures decreases from surface to bottom because the first surface is heated first and therefore heat is transmitted to the lower parts. 3 is the mixing of or upwelling of surface and deep waters. So those 3 factors will influence the temperature of the ocean, that is the latitudinal position of the ocean, the depth, and the mixing or upwelling of surface and deep waters. So generally, ocean water temperature decreases with the depth except in the polar regions or in the poles. Next is the ocean topography. And ocean topography is composed of various features such as the continental shelf. We have the continental slope. There is abyssal or deep sea plain. We also have the oceanic island, mid-ocean ridges, and the sea scarps. So just like the dry earth surface, which is composed of various features, the ocean bed also have got various features here. The only difference is that it is covered with water. So the first one is the continental shelf, And this is the relatively flat part of the continent, which is covered by ocean water. It is characterized by the following. It is shallow, that is about 180 meters deep, and gently sloping. The width varies between 120 to 160 kilometers between places. Some have islands formed by marine erosion and coral reefs. It contains depositional materials brought in by rivers and spread out by currents. That is the continental shelf. The next one is continental slope, and this is a steeply dipping surface between the outer edge of continental shelf and the ocean basin. Next we have the abyssal or deep sea plain, and this is the flat and almost level area of the ocean where mud or other sediments from the continental shelf and continental slope are deposited. These plains, which generally extend from the continental slope, rise to the mid-oceanic ridges, as can be shown in the diagram. They are the deepest part of the ocean, with the exception of the deep sea trenches. We also have the mid-oceanic ridges and sea scarps, and these are found within the ocean waters where they are submerged, with various heights forming volcanic or formed through volcanic and seismic activities. Those formed through faulting are normally called sea scarps. We also have the oceanic highlands, as can be seen on the diagram. And an island is any comparatively small body of land completely surrounded by water. There are three types of oceanic islands. We have the continental highland, continental highland, and this rise from the continental shelf and are structurally similar to the neighboring continental landmass. They form as a result of submergence of upland coasts due to isostatic or climatic changes. Examples of continental highlands we have Pemba, Lamu, Zanzibar, Malagasy, Sri Lanka, Indonesia, Philippine Islands, Newfoundland, and the British Isles. Apart from continental islands, we also have volcanic islands. And this rise from the deep sea floor. Volcanic eruption within the sea builds up islands where the materials pile up above the sea level. The example we have the Canary Islands, the Cape Verde, and the Seychelles Island. Lastly, we have coral islands. And this may be found both on the continental shelf and in the deep sea. Accumulation of coral into reefs becomes coral islands. Example, we have the Bermudas of Atlantic, Aldabra, and Maldives of Indian Ocean. So those are the three types of oceanic islands that we have. It should also be noted that islands may also form through the following ways. One, as the coastline retreats due to marine erosion, resistant rocks are isolated as islands. And two, deposition of materials across bays, river mouths, and lagoons build up barriers or islands which project above the water level. So that is oceanic islands. Still on the ocean topography, we have the deep sea trenches, and these are narrow, deep-sided submarine valleys on the ocean floor. They occur when the ocean crust is destroyed and where the ocean plate melts by sliding under the adjacent mantle. They are associated by guyots and seamounts, as can be seen in the diagram. Buoys are submerged atolls forming on underwater mountain with a flat top within the ocean water. Seamounts are volcanoes that do not rise above the sea level. So that is deep sea trenches, and generally that is how the ocean bed looks like. That is the ocean topography. Nature of ocean water also include ocean life, and the ocean water forms habitat of organisms. These include planktons. We have planktons, we have nekton, and the benthos. These are forms of life within the ocean water. So ocean plants are normally known as or called phytoplanktons, while the animal planktons are called zooplankton. These live near the surface of water. On the other hand, nekton are all swimming forms of fish, from the tiny herrings to huge whales. They occupy from bottom up to surface water, and these normally come to the surface to feed on the planktons. Then we have the benthos, which are ocean creatures that live only at the bottom of the ocean water. Examples: we have the corals, we have the snails, we have the starfish, slums, among others. And it should be noted that corals are the benthos that live in warm equatorial waters, and when they die, they form the coral reefs. So that is ocean water. Lastly, we have ocean pollution, and this is the most recent aspect of the nature of ocean water. Pollution results from human activities like industrialization. Pollution therefore introduces substances that cause harm to ocean life. Pollution can also be as a result of silt and sediments that are brought from the hinterlands that cause harmful change in the ocean water. We also have oil spills from sea vessels that also lead to pollution in the ocean water. So that is the nature of the ocean water. Movement of water in the oceans, and it should be noted that ocean water is not static. That is, it moves vertically and horizontally, covering many kilometers and great depths. Only a portion of water in the ocean is involved in these movements, and not the whole mass. So we have vertical movements and horizontal movement in the oceans. So we are going to look at each of the movements. So we have vertical movements, and vertical movement refers to the rising of water from the ocean bottom to replace the sinking water from the surface. Vertical movement is caused by 1. Difference in density of ocean water. So density of ocean water depends mainly on the temperature and salinity. Density is lower within the tropics where the water is heated, and is denser or higher in the temperate and polar areas because of the low temperatures. So in the poles, the cold dense water tends to sink, after which it moves horizontally towards the equator at low depths, while the less dense water of the tropics tends to move to the poles through the action of wind. The cooler water below rises to take its part or place. So that results into vertical movement. So when a mass of ocean water with the high salinity meets another of low salinity, the more saline water sinks below the less saline water because it is denser. That will also result into vertical movement. Another cause of vertical movement is convergence of ocean currents, and upwelling of water can also form at a place or a meeting point of two converging masses of surface water. Upon converging, sinking occurs. At the lower depths, the sinking water diverges after it moves horizontally. So that is how vertical movement occurs, either due to difference in density or convergence of ocean currents. We have horizontal movements, and these are movements of water across the ocean waters. So they occur across the ocean waters, and it occurs in three ways. We have ocean currents, we have tides, and the waves. So we are going to look at the three ways in which horizontal movement occurs. The first one is ocean currents, and an ocean current is a mass of surface water which covers a considerable distance and depth, and which is moving in a distinct direction. So ocean currents are caused by, one, we have winds, and as the prevailing winds blow, they encounter friction with the surface water in the ocean, causing the water to move in the direction of the wind. Ocean currents that result from movement of winds are called drift currents. Examples: you have the North Atlantic drift current caused by the westerlies. The second cause is the rotation of the earth, and this affects the direction of winds and that of ocean currents. In the northern and southern hemisphere, winds and currents are deflected to the right and left respectively. This phenomenon is called Coriolis effect, which causes a body in motion to be deflected from its initial path due to the Earth's rotation. The third cause is shape of the landmass. When an ocean current flows from the ocean towards a landmass, it changes its direction and follows the outline of the coastline. In some cases, a current may be split into two when it meets a landmass. Example: here we have the South Equatorial Current split by Madagascar Island. When a current flows through a constriction between landmasses, its velocity increases on leaving the area of constriction. Such a current is referred to as a stream current, and an example is the Gulf Stream current. The fourth cause is the differences in water temperature and the density. And here we can note that the warm, less dense water in the tropics tend to move polewards, while the polar, cold and denser water sinks and moves equatorwards, where it rises to replace the tropical water. So those are the causes of the ocean currents. We have the winds, we have the rotation of the earth, shape of landmass, and differences in water temperature and density. We have characteristics of major ocean currents, and these include: one, generally the ocean currents that flow from the equator or low latitude areas toward the poles are warm because they originate from areas of high temperatures within the tropics. Two, ocean currents which flow from the poles or high latitude areas towards the equator are cold because they originate from the cold areas. Characteristic number three, ocean currents which flow in the northern hemisphere generally move clockwise, while those flowing in the southern hemisphere move anti-clockwise, and that can be seen in the diagram. Number four, the warm ocean currents are found on the eastern coasts of continents, while the cold ocean currents are found mostly on the western coast of continents. The fifth characteristic is that convergence of ocean currents tend to occur on the eastern coast, while divergence tend to occur on the western coast of continents. Lastly, ocean currents are less developed in the northern part of Indian Ocean because the monsoon winds interfere with the smooth flow of the currents. So those are the characteristics of the currents. Then you have the distribution of ocean currents, and it can be noted on the map or diagram that we have the warm currents indicated by the red color and the cold currents shown by the blue color, and how they are distributed on the surface of the earth together with the names of the various currents. The second way through which the horizontal movement occurs is the tides. And tides are simply the periodic rise and fall in the level of the sea and other large water bodies. All water bodies are held onto the earth by the force of gravity. The moon, and to some extent the sun, also exert the gravitational pull on the earth, including its water bodies. This results in the bulging of water. So we have causes of tides. The first cause is rotation of the earth. Rotation of the earth brings any point on the earth's water surface under the influence of two high and two low tides during the lunar day. And the lunar day here refers to time taken by the earth in rotating once in respect to the moon. At high tide, the level of water rises and covers most of the beach, as can be seen in this